I think we need to look at some of these double displacement reactions and figure out just exactly how to go. A lot of you are pretty good at predicting solubility. You're not great at writing the proper formulas. So let's look at sodium chloride and silver nitrate, so NaCl and AgNO3. First thing you guys have to realize in double displacement is either outside goes with outside and inside goes with inside, or what might be even quicker is just realize that the two metals, they just switch place with the non-metals. And so sodium is a metal and silver is a metal. Metals are always written first in these compounds. So I'm going to put sodium where silver is and silver where sodium is. And so silver, let's change color here. Whoops. Let's change color. We'll go green. So silver now is where sodium is, and sodium is where silver is. Now, silver I told you was 1 plus. Sodium you have to figure out. Sodium is group 1, and so we know that it is also a 1 plus, which is going to make this nice and easy. Chlorine can stay where it is, so silver is now with the chlorine. NO3 can stay where it is, it's NO3. How do I know what the charges are here? Well, chlorine is group 17, so that means it has 7 electrons. It wants to have 8 electrons, which means it adds 1 extra electron to be negative. NO3, as soon as I see 2 capital letters and any numbers, if I have 2 capitals, it means there's multiple things there. It's called polyatomic. Poly means many, atomic means atom, so many atoms in a group. You look this up on your chart and you find it's called nitrate, and you find that that's 1 minus. And a lot of you can get to that point. You're doing just fine up until here. What happens after this is kind of unfortunate, because you've done all the hard work and the easy stuff we're kind of screwing up on. So what do I mean by easy? Well, all I need to do is balance out these charges. So the silver plus and the Cl minus, they need to cancel out. I need to have the same number of positives as I have negatives. Now in this case, if I have a 1 positive and a 1 negative, that does cancel out. That does balance out. And so my formula, the answer that I would write would be AgCl, to be a plus there. Same thing here. I have 1 plus and 1 minus. That balances out just fine, and so I have an Na and an NO3. Now, a lot of people have put brackets around this, and that's good. It's a good way to kind of, in your head, tell yourself that that's one thing, that whole thing. N and 3 O's all together is 1 minus. But if I have a little imaginary 1 here, I don't need brackets. I don't need to have brackets, because we recognize as chemists that if there's one of these groups, that's a group. We just recognize it. So NaCl plus AgNO3 produces AgCl and NaNO3. You guys are pretty good at predicting solubility. If you look on your solubility rules, you'll see that all chlorides are soluble with a couple exceptions, and all group 1s are soluble, so this is soluble. You could also say, hey, Mr. Taylor, when I did the lab, I saw it was soluble. All nitrates are soluble. There are no exceptions, so it's soluble. If I look up chlorides, chlorides are soluble except with, and silver is one of my exceptions, so that means that it's not soluble. And if it's not soluble, it's a solid. All nitrates are soluble. All group 1s are soluble. So that's going to be AQ for aqueous. And that was done pretty well. Let's look at this one. I'm going to start with green because I think the green's a little bright. I need to do the same thing. I need to recognize the metal. Well, this one here is potassium, and this one here is iron, and they need to switch spots. The iron needs to now go over here and be with the chromate, and the potassium needs to come over here and be with the chlorine. So let's do it opposite. So that means iron came over here, and potassium comes here. Now notice I didn't bring the 2. The 2 has nothing to do with my new formula. The 2 has to do with this, with the chromate. But it's not with chromate anymore. It's with the chlorine. So Cl. And the Cl and the K go together in a different ratio than the chromate does. Same thing with the iron. My Cr O4 right here is now with iron. And so these numbers only go with that particular formula. They don't transfer over. So some of you got behind the 8 ball because you wrote K2 here because you thought that that group had to go together. No, I think the confusion is, how do I know if it's a group? How do I know if it's not? If it's one atom, then the number you ignore. You just bring it over. If it's a group of them, like this is a CR with an O4, the O4 needs to come over as O4. But how many of those groups we have, we don't know yet. It depends on what the iron is. So I told you iron was 3+. So that I gave you. CrO4 you have to look up. CrO4 I'm actually going to look up right now. I think it's 2-. Actually, you know what? I do know it's 2- because potassium is 1+. So 2-. You just look that up on your chart. You find out that that's 2-. Potassium is group 1. So you need to know that that makes it 1+. And Cl is group 17. So it's 7 electrons. I add 1. That makes it 1-. So if I was to do this one again, 1+ and 1- work out perfectly. And so my final answer for that is just going to be 1K and 1Cl. Not Cl3, not K2, because it works out fine, plus and minus. Now we'll take care of these numbers when we do balancing, but for now, for this test, that's all you need to be able to do is KCl. Iron and chromate, little different story. So back to red workings. Iron is 3, chromate is 2-. I have more pluses than minuses, so I need another chromate to try and balance that out. 2-. 2- and 2- is 4-. I only have 3 pluses, so I need more pluses. Only way to get pluses is another iron. So 3+ and 3+ is 6+. 2- and 2- is only 4-, so I need more chromate. 2-. 2, 4, 6 minuses, and 3 + 3 is 6 pluses. So that now totally evens out. So that's going to be my formula, and I rewrite it in special notation. So instead of writing all what I wrote up there, I just say I need 2 Fe's, 1, 2, that one, and that one. And I need 1, 2, 3 groups of chromates. So I need CrO4, but I need 3 of them. And in this case, I need the brackets, because I need to say, hey, I've got CrO4. I've got 3 groups of that. If I don't have brackets, oops, probably an easier way to do that. CrO4, 3. That means I have 1 chromium and 43 oxygens. But that's not what you mean. You mean you have this group of CrO4, I have 3 of them. And so that's when I do need brackets. Alright, last thing. Use blue. Chromates tend to be soluble. So with potassium, it's going to be. Chlorides are soluble with a few exceptions, but the iron is not an exception, so this is soluble. I'm just looking at my solubility here. I'm sorry, chromates tend to be insoluble except with group 1. So potassium is group 1. That's how we got aqueous. Well, if they tend to be insoluble except with group 1 and NH4, this is not NH4 or group 1, so that would be insoluble, means it's not soluble. And chlorides tend to be soluble. Group 1s also tend to be soluble. There's 2 rules there, so this is definitely soluble. And so I'm going to end up with, we do it in black, K2CrO4 aqueous plus FeCl3 aqueous produces Fe2 bracket CrO4 3 solid plus KCl bracket AQ. And there's our answers.